second part of 11.4 talks about composite figures, and essentially composite figures, we're just going to break them down into smaller polygons that we know to have find the area of, like a triangle or a rectangle or a circle, maybe even a trapezoid. Okay, and then we're going to find each of those areas individually and then add them together or add and subtract, whatever the situation may call for. Okay, so example 1 here, we do have a pentagon, but it's not a regular pentagon. So what I'm going to do, what I see at least, I see if I would put a line in right here, I have a trapezoid on the top and then a rectangle on the bottom. Okay, now 5 inches goes here, which means that up here is just 7 inches. So I'm going to ignore this 12. Okay, this part up here, we'll do this in 2 different colors. Up here, this light blue part is a trapezoid. So 1/2 the sum of the bases times the height. Okay, remember the bases are the parallel sides. They are not going to touch. So one base is 8. The other base is 15. This can also go right up there. Okay, the height of my trapezoid is 7, which means that the area of just that top portion is 80.5. Okay. The bottom portion here is a rectangle. Area of a rectangle is just base times height. So I'm going to take 15 times 5 for an area of 75. Okay, and then I'm going to take these 2 pieces and I'm going to add them together because this trapezoid and the rectangle are stuck together. So the area of this composite figure is 155.5 square inches. Okay. Example number 2, I've got, when I look, I see a trapezoid on the left and a semicircle on the right. Okay. Now the only thing that stands out to me first, I don't know what the height of this trapezoid is. Okay. But if this is 22 and all of this down here is 31, that makes this portion 9. 9 squared plus whatever the height is squared gives me 15 squared. So my height ends up being 12. Okay. Not only is my height 12, but the diameter of this semicircle is 12 also. Okay. Again, I said trapezoid. So this whole left part here, I'm going to find the area of. Again, half the sum of the bases. One base is 22. The entire other base is 31. We found our height to be 12. So the area of this trapezoid is 318. Okay, the semicircle over here, I'm just going to take half times the area of a circle, so pi r squared. Okay, we said that the diameter of this was 12, which means the radius is 6. 6 squared is 36, and half of 36 is 18. So the area of that semicircle is 18 pi. Okay, if you are asked for an exact answer, we have to leave these separately because of the pi. Okay, so the exact answer would be this many square centimeters. Okay, but we can also write an approximate answer and actually multiply 18 times pi to get a decimal, and then add the 318 to it. So the approximate area then would be 374.55 square centimeters. Okay. Example 3, when I look at this, I see again another semicircle and a triangle. All right, the diameter of that semicircle here is 3 feet, just like the base of that triangle is going to be 3 feet. Okay, so the area of the semicircle over here on the left, top of that snow cone, is 9/8 pi. Okay, the triangle over here, though, on the right, area of a triangle is 1/2 base times height. Again, the base of that triangle is 3, the height of the triangle is 7. So the area here is 10.5 square feet. To find the total area, we're going to add these two together. Okay, and again, if you want the exact answer, since 10.5 does not have a pi with it, we would leave it like this. Okay, but we can also turn that to an approximate answer, which would be about 14.03 square feet. Okay. Example number 4. I see an isosceles triangle stuck to a rectangle. Okay. Now the triangle here. Okay, if all of this is 20, but just this portion is 5, that means what is left here is going to be 15 meters for the height of that triangle. Okay, the base is still 12. So base is 12, height is 15. 1/2 times 12 times 15 gives me an area of 90. Okay. The rectangle over here on the right, multiplied 12 by 5 for an area of 60 square meters. Okay, we're going to add those two together, 90 and 60. Since there are no pi's with this, we can answer not feet squared. We can combine those two to get an area of 150 square meters. Last two examples here. I know I've got 3 different sections here. Okay, this middle part is a rectangle. But I do have 2 semicircles, and if I put 2 half circles together, that gives me 1 whole circle. So I'm just going to do pi r squared. Okay, my radius is 15/2. If you want to use 7.5, you can. Okay, but the exact area of these, like the 2 ends here, is going to be 225/4 pi. Okay. this middle rectangular part, we will take the base of 30 times the height of 15 for an area of 450 square centimeters. We're going to take both of these, add them together. Remember, if you want an exact answer, you cannot add something that has a pi to something that does not have a pi. They have to stay separate, okay? But if we want the approximate answer, that is about 626.72 square centimeters. Okay, number 6 is a little bit different, okay, because we don't have things stuck together, we actually have a cutout. Okay, so I do see a rectangle, but then I've taken out a semicircle. Okay, so I'm going to start with the rectangle as a whole. Okay, rectangles, we just multiply the base times the height. 1,500 feet squared would be the area of the whole rectangle. Okay, but we don't want the area of the whole rectangle. We just want the area of the rectangle that's left after we cut out this semicircle. Okay, now the diameter of that semicircle is 30 feet, which means my radius is 15. Okay, so the area of the semicircle is 225 over 2 pi square feet. Okay, and this time instead of adding these two together, I start with the big shape, which was the rectangle, and I subtract what we took out, so that's semicircle. Okay, and again, we can't do anything other than write it like this when we've got something that has a pi and doesn't. Okay, an approximate answer, if we take 225 divided by 2 and multiply it by pi, and then take that away from 1,500. 1,146.57 square feet. Okay, get into the practice putting both the exact and the approximate for these composite figures. Okay, it will depend on what the directions are for your quiz.